Righty. Okay, so the pitching machine I'm thinking about is the one that's got looks like two giant buffer wheels that touch like that, right? You put a baseball, you feed a baseball in there, right? And these things are spinning like this, right? And the baseball gets shot out like that, right? Okay. Notice that we want the speed in RPM. So what we're going to do is we're going to use this guy and solve for omega. So let's do that. V is omega r, right? So the linear velocity is 41 meters per second. And then that's going to be omega times, and then our this is the diameter, right? So our radius is half that, so 0.60 meters, right? So let's figure this out. 41 divided by 0.6 is 68.3 bar. And that's radians per second. Okay, but now we want RPM, right? It says what is the speed in RPM? So we can do this, right? We go 68.3, and that's radians per second. We ultimately want rev per minute, right? So I'm going to multiply by two fractions. Okay, the top and bottom must be equal to each other, otherwise we'll change the number, right? So let's get rid of seconds. Let's go seconds and minutes. Okay, so how many seconds? Well, 60 seconds equals 1 minute, right? And the seconds, of course, go the way of the bison. I put the seconds on top on purpose to cancel that. These guys are equal. 1 minute equals 60 seconds. 60 seconds is 1 minute. Okay, so this has the value of 1, right? Let's see, radians. I want to get rid of radians. Apparently I want revolutions. All right, so what's equal? Well, 1 revolution is 2 pi radians. So I'm going to take this number on my calculator, go times 60 divided by 2 divided by pi. Because I'm too lazy to use parentheses. So I get 652.53 revolutions per minute, which is about 653 revolutions per minute. Okay, so in that case, when you solve for these things, it will be in radians per second, and so all we have to do is a unit conversion afterwards. Okay.